6, section 4 today is what? Okay, we're looking at, there it is. That's the one. We're looking at what do medians and altitudes do of a triangle. So the first thing we need to understand is what's a median for a triangle and what's an altitude for a triangle. We already know what an angle bisector and a perpendicular bisector do, so we're going to look at 2 other parts in terms of what they do today. So, 6.4 is titled Medians and Altitudes of Triangles. Michael, you want to read the essential question for me, please? Mr. Frizz?
Essential question. What conjectures can you make about the medians and the altitudes of a triangle?
Okay, so I want to make sure you pay attention to this because this is, we've got a lot of things going on here. Some of these are going to get confused with each other. So, yep, what conjectures can you make about medians and altitudes? So our goal is to use medians and find the, what's the word here? Centroids, okay? Anytime you're using medians, medians are going to have a point of concurrency that's called the centroid of a triangle. We'll talk about what that means. Then we're also going to talk about an altitude, okay? An altitude of a triangle is going to be used to find the, what's this word? Orthocenters, okay? Dentists like this. I know a dentist that likes orthocenters. All right, here we go. We need to understand some vocabulary big time. And we want to put these meanings in picture form. So, how about median of a triangle? Volunteer to read median of a triangle. Okay.
The median of a triangle is a segment from a vertex to the midpoint of the opposite side.
So, here's what I want you to make sure you understand here. Here's a triangle. Draw your triangle. I don't care what your triangle looks like. Make it kind of close to mine, okay? It says it's a segment from a vertex to the
Midpoint.
Okay, so this might be a midpoint right here. I'm just going to put M in for midpoint right here. This segment and this segment would be equal. And then do you guys agree that up here, this is the vertex that's opposite of that?
Oh, yeah.
So a median is a line that comes out of the corners. It's not bisecting the angle. It's not cutting the angle in half, but what it's doing is it's leaving from an angle and it's heading down to which point on the other side? And if you construct from the vertices of that triangle and go to the midpoint of its opposite side, those are medians. And those medians are all going to be at a point of concurrency, and that point of concurrency is going to be called the centroid. 3 what?
Medians of a triangle.
3 medians of a triangle are concurrent. The point of concurrency is called the centroid. The centroid would be like the center of gravity for it. It's like the one point. You ever, gosh, I got this. You ever tried to take something and balance it? Something that's flat and balance it? You guys kind of call that point the center of balance or the balancing point. The centroid is kind of like the balancing point for a triangle where you can just put it on your tip. Okay, makes sense? All right. So, centroid is found by the intersection of what, kids? Medians. And maybe write that. Centroid is found by, it's where medians do what? It's where the medians intersect. You bet. I like that. That's what you really need to know about a centroid. You understand what a median is right up here. So where all 3 medians cross, that's going to be the centroid of your triangle. Okay, kids? All right, then we need to understand what an altitude is, because an altitude, and maybe I'm going to do this. I'm going to draw an arrow between these 2 definitions right here because they go together. Same thing with altitude of a triangle as it relates to orthocenter, okay? The altitude of a triangle is it's a big word here. What's the word? Perpendicular segment from a
Vertex.
to the
Opposite side.
okay, or to the line that contains the opposite side. Sometimes that line might need to get extended. Let me show you about this. I'm going to make a goofy triangle, okay? Here's a goofy triangle. Maybe that goofy triangle right there. I'm going to make an obtuse triangle like that. I think that would be a good one to talk about because sometimes, and here's what I want you to think about in terms of altitude. Altitude is like the height of a triangle, okay? And altitude is kind of like the, and I'm going to write that right in here. Altitude is kind of like the, what of a triangle? I have a question. If I was looking at this bottom base down here and this vertex clear up here on the top left, would that height be an inside height or an outside height?
Inner.
Okay, you've got to form a perpendicular segment from the vertex to the line. Sometimes you might have to extend a line. Here's your altitude right here, because what angle needs to form? Is there any way that if I start at this vertex right here and I draw a line to the opposite side is down here, am I ever going to form a 90-degree angle?
No.
So it's sort of like the
Okay.
range, the high
Okay.
part.
Yep. Okay, another one might look like this, kids. It might go from here straight out to here. That's an altitude. Okay, because from this vertex to the opposite side, what angle am I forming? 90 degrees. So altitude is like a height. It's like a base and a height that we're comparing. Okay.
So just one of the sides has to be 90.
So you can do it from any direction, right?
You can do it from any direction. And here's the deal about this right here. Are these two lines going to intersect inside the triangle or outside the triangle?
Outside.
They would intersect outside, so it's possible that the orthocenter could fall outside of a triangle. So the orthocenter is where altitudes do it. Okay, so let's talk about this, kids. Down here we have some other points for our vocabulary, and we know these already. This is kind of a review, but a midpoint. You guys know what a midpoint is?
Yep.
If I have a segment that's 12 units long, where's the midpoint? At 6 units, okay? All right, if 0's on the left, 12's on the right, midpoint is 6. So you know what a midpoint is. So we're good here. This is review. Okay, concurrent means just lines that do what?
Cross.
And concurrent lines meet at a point of what?
Intersection.
And we call that point of intersection sometimes the point of, it's where they intersect, okay? So vocab-wise, here's the deal. Medians cross. Medians form what of a circle? What are they going to call? So what? A centroid, okay? The altitudes cross. The altitudes meet at that point of concurrency. That point is called the, okay. And I'm going to try and get you a chart put together here in a little bit.
It's going to be hard to
Try to remember all of these here, okay? And in fact, I'm going to take you to a page number in your online and show you where that's at to help you keep all this straight. But let's get started here, kids. Second page right here. Theorem. It's called the Centroid Theorem. Okay? This is pretty cool. Centroid Theorem. How about a volunteer to read my Centroid Theorem? Thank you, Michael.
The centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. The medians of triangle ABC meet at point P, and AB is 2/3 that, and BC equals 2/3 of BF, and yeah.
Did you say BF?
I don't know. I can't see that far.
Well, you gotta read it, right?
Yeah, then I have to flip it.
Yeah, you have to flip it.
Now I gotta like fold it.
Fold it, flip it,
Now I
hurry.
gotta put it down. Now to make it sound. Now we're good.
Okay. So, gosh, you know what I think would be really good here? You want to know what I think would be really good here?
That's most.
It would be really good, but I think that we should maybe get a triangle thrown in up there. What do you guys think? You guys want to do that? Okay. I'm going to do my best to draw a triangle. Let's draw a triangle ABC. Okay, I'm going to draw a triangle ABC. Are you okay with that? Here's A to B to... Oops, didn't want to do that. I wanted to do this. Okay, there's triangle. Let's label this. Triangle A, B, C. We're going to see how this works, okay? First of all, kids, it says centroid theorem. So centroid theorem is going to be based on what type of lines are we drawing in the triangle? There are going to be lines across, specifically the name of those lines, kids.
Median.
Medians, okay? Now, you might want to draw with some straight edges. I'm going to send the rulers around there. If you want to draw the straight edge, great. If you're really good at drawing or have some other tool to draw straight edges, that's great. I'm going to draw some medians in here as best I can, okay? So that means I need to go from each vertex to the opposite side. Does that make sense to you? So check this out, kids. Here's what's happening with the centroid theorem. I'm going to do my best to measure and figure out where my midpoints are and then draw a line. So give me a second. I need to find my 3 points and then I'll draw them. Okay? So while the rulers are going around, maybe construct a kind of a nice triangle like I have. Triangle ABC. And let's see what we have here. So that's about 9. So now children.
Hey, we're recording. Oh my god.
13 and a half. What's half of 13 and a half? 6.75. Good. Okay, and then I'm measuring A to C, and A to C is about 17, so half of that's 8.5, right? Right. Just say good, Parson. Good job. Good job, Parson.
Good job. A+.
All right, I'm going to put... I'm going to put some points in here. You might want to do the same. Okay. You guys yell at me when you've got rulers and you're kind of caught up with me. I'll give you a minute here and wait, okay?
We have the exact right number.
We do? That is so cool.
What do we have to say?
I mean, it looks like a total.
How far can this go?
Does anyone know how potato forms? Like, I don't know what that means.
No, not see my drawing.
Okay, have you guys pretty much all got everything drawn? Yep. How about you guys? All good? You guys up to speed with me right now?
Yeah.
Wall people, you all up to speed with me?
Yep.
Okay. Okay. So here's what I've done, kids. Since we're talking about medians, we're going to be drawing lines from each vertex to which point on the opposite side. What's this point called over here? The midpoint. So we're going to draw medians in here. So what I need to do is we need to label these points. Okay. So I'm going to call this point D. I'm going to call this point, let's see, B, A to E. I'm going to call E right here, and I'm going to call this F down here. So within each one of these, we need to draw a median. So I'm going to make the medians a different color here. I'll do the best I can, okay? You guys agree that looks like one median there?
Yeah.
So what's going to be true about the distance from B to E and from E to C? It should be the same because E is the midpoint of which segment? B to C. Okay, so I'm going to draw these all in here. I'm going to go from C to this midpoint right there, and I'm going to go from B to F. By golly, kids, do we hit a point where all three lines intersect? We have us a centroid right there. Okay, it's kind of like our balancing point, if you will. So I'm going to call this point here in the middle. This point right here is my centroid, and it meets at point what, kids? Okay, well, I actually went through and measured exactly where the... Okay, you want to measure exactly where the midpoint is. If you make a side 4 inches long, the midpoint should...
I didn't even measure.
I just need a really big point.
Okay? So, just make it kind of close right here. Here's what I want you to understand. These are all medians, so these are all midpoints. Okay? This is my centroid. We're calling this point P right here. Now, I want you to read this, kids. It says, and this is what I'm going to highlight right here. This is what I think is most important right here. AP is equal to what? From A to P right here, it's equal to 2/3 of what? Okay. If AP is 2/3 of that whole segment, then P to E would be what fraction of that whole segment?
1/3.
So if there's 2/3 here and 1/3 here, it's like for every 2 I take here, there is 1 unit here. So listen to what I say here. What if the distance from P to E was 4 units long? Then what would A to P have to be according to this theorem?
If it was 4 units long, then the other one would have to be 8.
8. So what I want you guys to do, think about this theorem. They throw 2/3 up there.
This is fun.
They say from A to P, it's 2/3 of A to E. Isn't A to E the whole segment? And AP is what fraction of that whole segment, A to E? 2/3 of it. If you can think of it this way, it means this. It means for the long part, there's a longer part for the medians and a shorter part for the medians from the centroid to the midpoint and the centroid to the vertex. The distance from the vertex to the centroid is always the longest part. So if I do this, kids, if I do this, I want you to think about the distance from the centroid to the sides as like a 2-to-1 ratio. And I don't know why I made it like that, but it's kind of cool. I like bubbly.
I like bubbles too.
Okay? Think of 2-to-1 ratio. Here's what I'm going to tell you. Okay? The distance from the vertex to the centroid is like 2 units for every distance from the centroid to the, what's this point over here called?
Median.
Okay, I'm going from vertex to centroid, centroid to midpoint, in other words, right? Okay, so the ratio is like this. The distance from the vertex to the centroid is like the 2, and the distance from the centroid to the midpoint is like my 1. So let's put this into play, kids. Take a look at this down here in example 1. We're going to use this idea of centroid theorem, which states that the distance from the vertex to a centroid is 2/3 of that overall ratio, or overall side, I mean, or, and that side being the median, or it's a 2-to-1 ratio comparing the vertex distance to centroid and centroid to midpoint. Well, what does that mean, Parson? Well, I don't know. So let's see if we can't figure it out. It says the triangle RST point Q is the what? Centroid. And we have a theorem we just talked about. And V to Q is what? Find what?
RQ.
And RV is a motorhome. Okay? Okay, let's look at R to Q. Okay, these are all medians right here. What's the distance from Q to V, first of all, kids? Okay. Is that distance from centroid to midpoint or centroid to vertex? Centroid to midpoint. So that would be like with the 1 unit, which means the other part of the segment is like 2 units for every 1 unit here. So the distance from R to Q would be what, kids? This distance from R to Q has to be 10. Well, okay. What's that make the distance from R to V then? 15. I have a question. That total distance is 15 then, right? I'm going to write this down. RQ was what distance again? What was RV?
15.
I have a question. That distance from the vertex to the centroid, you with me, was 10. What was the overall distance of the median? What fraction does 10 over 15 reduce to?
1 to 2.
2 over 3. That distance from the vertex to the centroid is 2/3 that whole median, right? Okay? Let's try something else. Let's find the centroid of a circle, kids. Ooh, this could be kind of tough. This could be kind of tough, kids. We have to be exact, and this is why you have rulers right here, kids. So let's do this. Let's do this. Okay? I'm going to blow this up. Ready? Boom! You guys need to tell me which points we're plotting in this first. So where's A? Can I go one more? Can I go just one more? Is that okay? Go for it, Parson. Is that what you said?
Yes, sir.
Okay, what's the first point, kids? 0, 4. What's the name of that point?
A.
A is right here. What's the next point?
B.
B?
-4, -2.
Left 4, down 2.
Yep.
Okay.
And then C, 7, 1.
So, oh, I do have 7. Awesome. Right 7 and up 1. This is so cool.
No, it's not.
You're not cool, Adam, so be quiet.
It should have been on a.
Did he bully you again? Yeah. Yeah, him. You want to look at his drawing? It doesn't good.
Let's not.
Yeah.
Look at your drawing.
Draw your triangle with a straight edge, please.
It would have been a lot easier if it would have been on a horizontal.
You want some cheese with your wine?
That'd be nice.
You should have seen this headlock I was doing yesterday. Where I can slam
Okay, I'll
back.
get time to draw that. Let me know when you have that all drawn in there.
Like, blind.
Yeah, he was like, is that the guy from
Lost those two.
Like, literally, the kid was here, and then here's me, and he went.
It was super hot on the guy. Like, big slap.
Yeah.
He was about to cry too.
Yeah.
And then
His coach was getting
the
so
coach
mad.
was getting mad because I slammed him.
Okay, listen carefully, kids. We think that centroid is defined by the intersection of which lines within the interior of a triangle. What are those lines called for centroid? Well, we have to go to a midpoint, but that vertex to the opposite midpoint is called the median. Okay, so we've got to kind of figure out where the midpoint is. So let's talk here, kids. In this example right here, let's go, what was this point over here on the right? Was this B or C?
C.
So this is C and this is B. Let's do A to B first, kids. Here's what I want you to do. We need to find a midpoint. We're going to find the midpoints of all these sides. Here's what I think you should do when we plot stuff in coordinate planes. First of all, to go to A to B, how far left do I have to go? 4, and then down how much? So think of those directions. Left 4, down 6. Cut that in half. Left 4 would turn into what?
Left 2, down 3.
We're going to go left 2 and down 3. And right here, you know what? Our midpoint's going to fall. Midpoint's going to fall right there at negative 2 comma what?
1.
To which eventually we will draw a line here.
And that's the midpoint.
Okay, and that'll be the median in there. Okay, we're going to find the midpoints of all sides. So let's go B to C. Guys, from B to C, how far up do I have to go? 3.
4.
No?
3.
1, 2, 3, right? And then how far right do I have to go to get to C?
12.
Ooh, I think it's 11, isn't it?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Okay. So what's half of up 3?
1.5.
Up 1.5. And then right how much?
5.5.
5.5, right? Half of 11 would be 5.5. So here's 1, 2, 3, 4, 5. Kind of be right here. And let's put some coordinates to these midpoints. This midpoint right here is going to be negative 2, comma 1. This midpoint right here looks like it's going to be 1.5 over and down how much?
About a half.
Half. So this is going to be 1.5, comma negative 0.5. Whew. Let's find the midpoint here. How far down do I have to go to get from A to C? 3. So I'd go down 1 and a half. And then over 1, 2, 3 and a half. And that puts me right about here, doesn't it?
Yep.
Okay, now, guys, my pen up here is really wide, and I'm not sure where they're going to intersect, and I'll shorten this up and scale this down. But why don't you guys, once you have those points plotted, what did we say C was going to be as a coordinate then? Over 3.5 and up how much? 2.5? Would you agree with that? Let's see where these cross, okay? Now, I love stuff like this because here's the deal. When we do this, how many lines do you really need to intersect? Just 2. So let's see if that... I like this one right here because I'm going to go from C across right here. This is just a horizontal line, isn't it?
Yes, sir.
Oh, it is. I didn't even know.
There's going to be one median. And then I'm going to go from A down to here to this midpoint.
So they don't look like they're all the same length. You know what I mean?
Okay, so let me scale down to normal size now. And they don't have to be same length, but guys, what point? Looks like for me I'm at about 1, comma 1. What are you guys
That's exactly
finding?
where I got
That's
mine.
where I put mine.
Is that what you guys are getting? 1, comma 1? How many got 1, comma 1 when they intersected medians there?
I don't.
Where's the centroid?
1.
1, comma 1. I want to do something here real quickly. We didn't even have to draw that second line. In fact, we didn't even have to do the other. And once we had that first midpoint, we could have been done.
Wow.
Let me show you why.
Why?
Because right here, that first line that we drew in there, that first median from C to negative 2, 1, this was what kind of a line? Could we count how long C to that midpoint was?
Yeah.
How long is this midpoint? Well, count with me. 1, 2, 4, 5, 6, 7, 8, 9 units long. Think of it this way.
So 1 6 and 1 3.
What's the cases?
What's 1/3 of 9? 3. What's 2/3 of 9? You simply could have said from vertex to centroid would have been 6 units long, and this would have been 3 units long. You would have known that by that 2/3 part from vertex to centroid. That's like the 2 part. And then centroid to midpoint, that's like the 1 part. If you've got 6 over here, that means this has to be 3. Could you have gone 3 units to the right here and found that you would have been at 1, 1 right here? You bet. So where's the centroid going to be? 1, 1. Okay, 1, 1. All right, very good. That's awesome stuff. That is good stuff. Hey, what do we got? One more page left, is that right? So we have this idea of centroids. They're found with the medians, vertex to midpoint of opposite side, okay? There's a 2/3 ratio that goes on in there. You need to understand that. Now, we also need to talk about what altitudes do. Well, altitudes help us find what's known as the orthocenter. So here's what we're going to do. We're going to find the coordinates of the orthocenter triangle DEF. Help me plot DEF, kids. What's D's coordinate first? 0, 6. So right here, right? What's E?
-4, -2.
Left 4 down 2. There's E. Where's my F? 4, 6. Right 4. Up. How much?
6.
Yes.
Oh my gosh, this is getting ugly.
No, I like this one.
Okay, go ahead with your straight edge and draw this. We got to find the orthocenter for this. I'll do my best to draw a triangle. What color triangle you want today?
Blue.
Blue it is.
No, red.
Red, orange, yellow.
Orange. Just compromise me.
How about this
Can I get a
shade of
rainbow
blue?
Yeah. That needs to be a
Boom.
rainbow.
That way you take everyone's.
Ah, that's not good. That ain't even triangle.
That wasn't a triangle, that was a square.
I don't think so. No.
I did pretty good.
You like butter, you will love. I can't believe.
Okay. Altitudes. Kids, what do you know about altitudes? What angle do they have to form? Right angles, okay? Right angles, what's another word that we can use if 2 lines intersect for a right angle? We say the lines are
Perpendicular.
perpendicular. What do you know about the slopes of perpendicular lines within the coordinate plane?
They're opposite.
They are opposite reciprocals of each other. So what I'm going to do, I'm going to make a note up here, and I'll say, when you're looking for orthocenter, you need to think slope, and think opposite reciprocals. Okay, kids, stay with me here.
I'm staying here.
So let's do this right here. Let's go from, well, D is the first vertex listed in the naming of our triangle, right? So let's go from D to the opposite side and we'll go perpendicular. So, kids, here's what we need to look at. We're going to start here at D. And we're going to go ahead and draw an altitude from D to the opposite side. So what we need to do is look at the slope from E to F, kids. What's your slope from E to F? How much do you rise from E to F?
8.
8. How much do you run from E to F? 8. So the slope 8 over 8 would really be what?
1.
1. So what would the opposite reciprocal of positive 1 be?
Negative 1.
Negative 1. So what we're going to do, guys, our slope from D to here is going to be a slope of negative 1. So what I'm going to do, I'm just going to say, well, all right, so I need to go down 1 over 1, down 1 over 1. And gosh dang it, wouldn't you know it, there's my first altitude right there. Now, I'm going to tell you, and I'm going to encourage you guys, when you do altitudes, extend them a little ways, okay?
I got you.
It's gonna be outside.
Might be, okay?
Is this stormy now?
Gosh, I hope we don't have, we might run into a situation where the graph is not going to be perfect. We'll figure this out. So what I want you to do is extend your lines a little bit. When you draw an altitude this way, I want you to extend it, first of all, this way a ways. Oh, what's going on here?
Careful.
Well, it has to be a 90-degree angle, right?
Oh, shoot, what happened there?
I was expecting.
Something is very wrong.
Wait, what?
Extend it this way, but also extend it which other way?
You're gonna have to, yeah.
You might have to go off the graph a little bit, and I'm okay with that. Okay, because we'll figure this point out, because we know we're always going over one, up one, over one, up one, over one, up one. I should change the color of that.
Oh, this is weird.
Okay, there's one altitude, okay?
You have to extend the other line of the triangle too.
Now, let's go from E. Now again, keep in mind, how many of these lines need to intersect to find these points? Do we need to do all three, or can we get by with just doing
Two is good.
two? But what's really cool is we got third line. Check.
Wow. Are we talking about money now? I heard check. Didn't know what? What are you doing?
Let's go from E to DF. Now guys, we got to form what angle from E to DF? We have to form what angle from E to DF? Problem is, though, that if I go E to DF, DF is horizontal, isn't it?
Yeah.
Which means E to DF would have to be a what? Vertical. Is E really going to hit that side DF in the triangle, or is this going to fall outside?
You have to extend it.
Yeah, we might have to extend. We might have to extend this line a little bit, right up there. That makes sense to you? You might have to extend that line up there a little bit.
But then you can't tell what the point is because it's outside and it's not
What's
on the
your
ground.
But we're going to figure it out here. Here's the deal.
Was math created or was it invented?
It was invented.
What came first, the math or the numbers?
So we need to like.
Oh, that was a good one.
Oh.
So, here's what we're going to choose to do. I'm going to draw this altitude in here from E, because this will just be vertical then, wouldn't it? Straight up here. I'm going to keep this going until it hits up here. Okay. Do you guys agree that my point of intersection is going to be somewhere up here? Okay, let's think about this. Now, I know it went off the graph a little bit, but is your orthocenter inside the triangle or outside the triangle? Okay, so here's the deal.
It looks like a cursor.
We know that we're at -1, 7 right here, right? Do you guys agree with that? I would be, and we've got to get over here. We've got to get over here until we're at -4, don't we? So I could go over 1. I'd be at -2, 8, -3, -4, 10. We can count this because we know the slope of this line is -1. So I can go over 1, up 1, and just keep counting here. So what did we say that this was going to be, kids?
-4, 10.
Okay. By the way, what angle's formed right here? Even though, again, I'm going from E to the side DF, but we had to extend DF a little bit, so we formed what angle here? Okay. Now, kids, don't confuse altitudes with perpendicular bisectors, because a perpendicular bisector would have been a line going right through here, right? You guys understand that? Okay. Bisectors, perpendicular bisectors, just bisect sides, and that's it. Right? All right, so let's look at this last example here. Proving a property of isosceles triangles. Prove that the bisector of a vertex, angle, in an isosceles triangle is what? An altitude. So let's label my triangle as follows. Let's label this A, B, C, and I'm going to draw a line right in here. And I'm going to put D in here. Okay? Okay, right here we go. Right? What kind of triangle is this? This is isosceles, which means this and this must be the same. So if that's true because here's the deal. If this point lies up here, if B is equidistant from A and B is equidistant from C, then that means any point on this line is equidistant from what? Okay. So what's that mean about the distance from A to D and D to C? They're the same, right? Okay, so what kind of angle does that make this then?
90 degrees.
It's 90 degrees because this is like a perpendicular what, guys? It's like a perpendicular bisector. If this is equidistant up here, anytime you have a perpendicular bisector, if these two sides are the same right here, then that means that angle must be 90 degrees. So what I'm going to say is this: since B is, what's the word I'm going to use in terms of equal distances? Equidistant from which two endpoints? From which two endpoints? A and C. Because triangle ABC was what kind of a triangle? Triangle ABC was, I can't even spell. Isosceles, isosceles, isosceles. Oh wait, they say Hercules in that movie, don't they? Hercules, Hercules. Never mind.
What movie?
Nutty Professor. Then BD must be a perpendicular, and we've got piggies in the class now. Must be a perpendicular what? Bisector for which segment? Who said it? Somebody said it. Perpendicular bisector of? Somebody said it. AC. So that means that D must be what kind of angle?
Right angle.
Yep. It says prove that the bisector of the vertex angle of an isosceles triangle is an altitude. D must be 90 degrees. Kids, going from B to D, if that's a perpendicular bisector, but it also goes from the vertex to the opposite side, forms a 90-degree angle, it's also an altitude. So the altitude in isosceles triangles is also a perpendicular bisector. Must be 90 degrees, meaning
Is it Fahrenheit or Celsius 90 degrees?
it's going to be degrees, right? I like 90 degrees Fahrenheit because this problem's pretty hot. Woo!
Celsius is hot.
90 degrees Celsius is terrible.
90 degrees Fahrenheit warmer. Well, 90 degrees Celsius, that would be bad.
Yeah.
That would be bad.
I'd be left.
Okay.
I'd be
You might not be alive. Okay, guess what, kids?